You ever watch a basketball player sink a perfect shot? That beautiful arc the ball makes. Or, the sweeping curve of a giant suspension bridge? Well, that shape has a name. It's called a parabola. And honestly, it's everywhere, just hiding in plain sight. So today, in this explainer, we're going to pull back the curtain and really decode what makes it so powerful.
So here's a question for you. What on earth connects that basketball shot we just talked about to how a company figures out its maximum possible profit? I know, it sounds totally random, but the answer is the exact same mathematical curve. It's the key to finding the sweet spot in pretty much any situation.
And there it is. This U-shaped curve is the parabola, which is just the picture you get from a quadratic function. Today, we are going to go way beyond the textbook to see how this one simple shape is used to make some really crucial decisions out there in the real world. All right, here's our game plan. We'll start with the basics, learning the language of the parabola. Then, we'll look at the two different ways to write its equation. After that, we'll get our hands dirty finding its key features and even try to build an equation from just a picture. And finally, the best part, we'll see how it's used for real-world optimization. Okay, first things first. We've got to learn to speak the language. To really get a handle on the power of a parabola, you need to know its key parts. The landmarks that define its shape and tell you what it's doing. There are really just three core terms you gotta know. The parabola itself, that's the U-shaped curve. Then you have the vertex. Now, the vertex is that critical spot where the whole curve changes direction. It's either the very bottom or the very top. And finally, the axis of symmetry. Think of it like a perfectly vertical mirror that slices right through the vertex, making one side a perfect reflection of the other. And get this, a parabola's entire attitude, whether it's happy or sad, comes down to one single letter, A. If A is positive, the parabola opens up like a smiley face, which means it has a minimum point. But if A is negative, it opens down like a frowny face, giving it a maximum point. So just by looking at that one little value, you instantly know if you're trying to find, say, the lowest possible cost or the highest possible profit.
So how do we actually write this stuff down in math terms? Well, a parabola can be described by two different kinds of equations. It's best to think of them as two different tools in your toolbox, where each one is perfect for a specific job.
Okay, so first up, you've got the general form. It's great for certain algebraic stuff, totally useful. But then there's the standard form, which a lot of people call vertex form, and this one is a game changer. It's incredible because it literally just hands you the coordinates of the vertex, the single most important point on the whole graph without any extra work.
So let's actually put these tools to work. On to section 3, finding the key features. This is kind of like our mechanics guide. We're going to get under the hood and pull out the most important bits of information, starting with that general form.
Right, so when someone hands you the general form, finding the vertex is a simple two-step deal. First, you find the x-coordinate with a handy little formula. X equals negative b over 2a. That right there, that's your axis of symmetry. Second, you just take that x value you just found and plug it right back into the function to solve for y. That's it. Let's see how it works with an actual function. Using our little two-step formula, we first calculate the x value, which gives us an axis of symmetry right at x equals 4. Easy enough. Then we plug that 4 back into the equation to find out what y is. And just like that, the math leads us straight to the vertex, the point 4, negative 6. But now, look at this. This is the magic of vertex form. For this function, f of x equals negative 3 times x minus 4 squared minus 1, we don't have to calculate a thing. The vertex is literally just staring right at us. The h is 4, just remember to flip the sign inside the parentheses, and the k is negative 1. So the vertex is 4, negative 1. It's just so much faster. Okay, now this is where it gets really interesting. We can actually work backwards. What if all you have is the picture, but you don't have the math? Well, section 4 is all about how to reverse engineer the formula right from the graph itself. It's a pretty clever three-step process. First, you just look at the graph and pinpoint the vertex. Step 2, you plug those coordinates into your vertex form equation, which leaves only A as the mystery piece. And for the final step, you just grab any other point on that curve, plug its numbers in, and solve for A. And boom, you've got the complete equation. So let's get to the crucial point. Why does any of this matter? Well, that brings us to section 5, real-world optimization.
This is where the parabola stops being a math problem and starts being an incredibly powerful tool for solving all sorts of practical problems. Optimization, it's kind of a fancy word, but all it really means is finding the absolute best possible outcome. We're talking maximum profit, minimum cost, the largest area you can get. And here's the secret. For any situation that you can describe with a quadratic function, the answer to that, what's the best question, is always, and I mean always, found at the vertex. Let's look at this case study. You've got a farmer. They have 164 feet of fence, and they want to build a rectangular pen next to a wall they already have. Naturally, they want to get the biggest possible area. Well, you can model this problem with a quadratic equation, where the area depends on the width of the pen. So how does the farmer figure out the absolute biggest area they can fence in? It's simple. All they have to do is find the vertex of that area function. The math tells them the perfect width is 41 feet, and when you plug that back in, you get the maximum possible area, a whopping 3,362 square feet, all thanks to knowing how to find the vertex. Now, this idea works for more than just fences. It's absolutely critical in business. Think about a phone company trying to price a new gadget. If they price it too high, nobody buys it. Price it too low, they don't make enough money. Their revenue is a classic downward-facing parabola, and somewhere on that curve is one perfect point of maximum revenue.
And to find that sweet spot, that one price that will make them the most money, what does the company have to do? You guessed it, find the vertex. A quick calculation points them to a single perfect price point. In this case, it's exactly $172. All right, let's do a quick recap of the key takeaways here. A parabola is a U-shape, and its most important feature is the vertex. We have two ways to write its equation, a general form and a vertex form, for different jobs. The sign of A tells you if you're looking for a maximum or a minimum. And most importantly, the vertex is the ultimate key to solving optimization problems.
Seriously, if you remember just one thing from all this, let it be this. When you're looking for the best possible outcome in a quadratic situation, the maximum, the minimum, the optimum, the answer is always the vertex. From figuring out the best use of farmland to setting the perfect price for a new phone, the vertex is the key to getting the best possible result. So now that you know how to find it, the real question is, what are you going to optimize?